Hi, I'm Shanaz. In this lecture, we characterize the projective modules. So we have this proposition. So it states that an R module P is a projective module if and only if for any surjective homomorphism phi from R modules A to B, where A and B are R modules, the induced homomorphism phi star from PA to home PB is surjective. So this R module P is projective if for this surjective linear map this induced homomorphism is also surjective and vice versa. Now let us prove this result. So first we prove the result for the free module. So if we first assume P is a free module, then this for this surjective linear homomorphism for linear map, this induced homomorphism is also surjective. So assume first that P is a free module. Let us consider this basis. So let EI, where I is in some index set I, be a basis of P. So P from A to B is given a surjective linear map or linear map. So we claim that this induced homomorphism P star from these two sets this is our claim that this induced homomorphism is surjective. Now to prove this claim, what we have to prove? We have to prove that if we choose any element in this set here, so I mean home PB, there must be an element in home PA such that phi star of that element is if every element in this set has a pre-image under this phi star. So let us choose an arbitrary element here. So let an element here is actually a linear map from module P to module B. So let alpha belongs to home PV. So such that, since alpha is an element here, so alpha must be a linear map from P to B. Now P is projective, so I mean P is free here. We have assumed that P is free, so we can define alpha like this. Alpha of EI is XI for all I in I, because this set here is basis of P. So P is here and this is our B here. So an element here EI, this is mapped to XI. Now here we have a module homomorphism phi. Now this phi is given to be surjective, since phi from A to B is surjective. This XI has a pre-image in A, so we can find some YI in A such that phi of YI is XI. So there exists this YI in A such that phi of YI is actually this XI. So for this XI we have this YI. Now due to this surjection we can define a linear map from P to A. So then we have a linear map say beta from P to A. Now if it is a linear map from P to A, so then this beta is an element here in home PA. Let us write this down here, i.e. beta is in home PA, such that, so this map is defined as beta of EI is YI. That is, the map is given as, since any element here is actually linear combination of these EIs, so we can write this, we can operate this beta on an element of P, which is actually a linear combination of these EIs, which is given to be sigma AI beta of EI, which is sigma AI. Now beta of EI is actually defined as, so it takes this basis element to YI, where YI is pre-image of this XI. So now if we look at this phi star, so what we have to prove? We have to prove this phi star is surjective. So we have to prove that the element chosen here, which is alpha, has pre-image under this map phi star. Now what we are going to prove? We are going to prove that this beta is pre-image of alpha. Now phi star of beta ei, this is actually phi of beta of ei, which is actually phi of beta of ei is yi, which is actually phi of y is xi, and xi is here given as alpha of ei. This is alpha of ei. This means that or this gives phi star of beta is actually alpha. So we have found a pre-image of alpha under this map phi star, which is beta. So this proves that this phi star is surjective. So this hence phi star is surjective. So we have proved that if P is free, then this inducer homomorphism surjective. Now, but we have to prove for the projective. If P is projective, then this phi star is what I mean. This phi star is surjective. Now we are going to assume that P is projective. Now assume that P is projective. So now if P is projective, then by definition then there exists free module F and free R module F and R module Q, such that this P is a direct sum of F, such that F is direct sum of P and Q. Now let us define this map. Let this pi from F to P be the projection map. Since F is the direct sum of P and Q, so every element of F can be expressed uniquely as, so if this element G is in F, so this G can be expressed as an element of P and Q. I mean like this, little p and little q, where P is in P and Q is in Q. Now we are defining this pi from F to P. Now what it does, it takes this element which is equal to this PQ, it maps this element to the first component. So this is the projection map. So now what we have to prove? We have to prove this phi star is surjective. We have to prove this phi star here, this is surjective. For that we choose an element here. So let us choose an element. So let alpha be in home, choose R PB. So it is like this. So this alpha is a map between P and B, and this pi is a map between F and P. So that means this composite map, alpha composite with pi composite with alpha, is actually a map from F to B. So then alpha composite with pi is a map between F and B, which is linear. So this is in home FB. But F is free module, and earlier we have proved that the assertion is true when this P is free. Since F is free, this means that let's write this down here. Now F being free, there exists some, so this P star must be so in place of P right now we have F. Now we have an element pi alpha in FB, so this phi star will be surjective. So there it's a map, an element here, home FA, such that phi star of that element is alpha. So there exists this say beta in home FA, such that phi star of beta is alpha, sorry, pi alpha, alpha pi. This is true because we have proved earlier the assertion is true when P is free. So we are applying that result on F. Now this beta is actually a map from F to A. Now this F is actually direction of P and Q. Now if we restrict this beta on Q, P, and call this restriction map as beta 1, then so let us write this down here. Let beta 1 be the restriction of beta on P. So if this is the case, then this beta 1 is actually a map from P to A, such that phi star of this beta 1 is actually alpha pi. Now in that case, pi will be the identity map from P to P, so this will be alpha. So this implies this phi star is surjective, hence phi star is surjective. Now let us prove the otherwise, I mean the converse part. Conversely, now what we are going to assume, we are going to assume that for any R module homomorphism P from A to B, the inducer homomorphism P star from home PA to home PB is surjective. Conversely, let for any R linear map for any surjective R linear map phi from A to B, the induced homomorphism, the induced R linear map phi star from home PA to home PB is surjective. So this is our assumption. We have to prove P is projective. I mean, we have to prove P is direct cement of a free module. So this is our assumption. Now earlier what we did, we proved that any R module M can be expressed as a quotient of a free module. So let us write this here as G, where G is a submodule of F, where F is free. Now we can express this P, because P is a R module, we can express this as a quotient of a free module. So express P as a quotient of a free module, say F. That means this P will be isomorphic to F mod some submodule, say G. If this is the case, then we have a surjection, say phi from F to P, because this is the first isomorphism theorem. If phi from F to P is a surjective R linear map, then F mod its kernel is isomorphic to P. Now in place of kernel of, so we can replace this, we can substitute this kernel of phi to be G. So this is if and only if condition here. I mean, if this is the case, then we have the surjection. Now if this is a surjection, we have this isomorphism here. So hence there exists a surjective R linear map, say phi from F to P. Now this P will induce a surjective, because this is our assumption, that is for any R linear map P from A to B, and this induced homomorphism is surjective. So let us call this psi. Or let us call this psi. So therefore the induced homomorphism, induced R linear map psi sub star from P to F. So in place of this, so we are taking this, at this component we are taking P, so psi star P to P. So in place of A we have F, in place of B we have P. Now when we apply this assertion here to this psi, we get this thing. So this induced R linear map is surjective.